Okay, we are back. This is Techmath1. We are looking at the chapter, well, I don't know, it's in with the chapter 5 stuff. 1, 2, 3, 4, the 5, 6 stuff. So, let's take a look. It's the precision accuracy handout. And so the difference between, there is a difference between precision and accuracy, all right? And let's take a look. To understand that also, you're gonna have to know what significant digits are. That's different than significant figures, like sig figs. If you did that in a different class, this is different than that, all right? So first, let's talk about precision. Precision is just like how far you measure things. So if I wanted to know what's the precision of each one of these, it's just basically the decimal place. So like number 5 here, 9.2, that's precise to tenths place. That's like how far they measured it out. They went to tenths place. All right? If they have a 0 added after the decimal like this, like 3.4 and then a 0, that doesn't have mathematical significance. That's still 3.4 or 3.40 or 3.400. But in a lot of like hands-on type stuff, machinists and such will add a 0 there to show you it's accurate to that place. It just didn't happen to be an interesting number. It wasn't 1 or 2 or 3 or 4 or 5 or 6, 7, 8 or 9. So, but they wanted to know it was accurate to that place, so that would be actually hundredths. So when they add zeros that aren't necessary mathematically, they are necessary for us to determine precision, all right, precision. Oh, and I think I just said accuracy. Ooh, I'm gonna not interchange those because they're actually two different things. All right, so precision. So this one is precise to hundredths place, tenths, hundredths. This one is precise to tenths, hundredths, thousandths, 10,000ths, right? Tenths, hundredths, thousandths place. Tenths, hundredths, thousandths place. So even though that is the same as 1 100th, you know, tenths, hundredths, thousandths, it's still precise to thousandths place because they added that extra 0 after. Oops, and I said thousands, and you gotta say thousandths. Make sure hundredths, 10,000ths, THS, thousandths, thousandths. All right, tenths again. Or actually, for the first time, we talked about it already though. 9.2 is tenths, tenths, hundredths. Or precision, this is all precision. Tenths, hundredths, thousandths, 10 thousandths, 100 thousandths. So that one's 100 thousandths. Tenths, hundredths, thousandths again. That seems to be a popular answer on this. Tenths, hundredths, thousandths, 10 thousandths. And tenths, hundredths, thousandths, 10 thousandths. All right. Now, significant figures are different than significant digits. We're talking significant digits. Digits, digits, digits. Sig digs. Significant digits. It's something that we kind of explore when we do scientific notation. You put the number part, and then you say times 10 to the 20th. And then instead of adding all those zeros, those aren't really significant. Like the number itself is significant. And so if you had something, well, let's just look at these and I'll explain as we do examples. So if I have 253 253,000. These zeros are of no consequence. If it was 253 million, there'd be obviously more zeros, but the information comes from the 253. That's where we kind of hone in on significant digits. So 253, that's only 3 significant digits. We basically don't count those zeros. Same going the other way. If it's a really, really small number, you have 0.0000000. Look, if I had this number, 12, that would only be 2 significant digits, just those two, where all of those zeros don't count as significant. Okay? Now, there is a caveat to that. If the zeros are trapped by numbers, even with a decimal in it. So if I put a 1 point and then all of those and then 12, all of those become significant digits then. Okay? But if it's just a string of zeros after or a string of zeros before the actual number part on a decimal, you don't count those. So there's 1, 2, 3 there. If they get captured, basically, look, the 8 and then a 0, then a point, and then a 0, and then a 2, there's significant digits on either side and zeros in between. Now those zeros become significant. Okay, so that is a 4. There's just 3 numbers there. That's 3. 932.00. So now we kind of go into that is precise to hundredths place. They put a 0.00 after, even though mathematically we didn't need it. It's the same as 932. But because they put it there, that means it was measured, and that means it becomes significant. So that if you go decimal and then add zeros after the decimal, when there isn't numbers pending there, those become significant. So that this is 1, 2, 3, 4, 5 significant digits there. 5 signigs. All right, so let's look at this. We have 4.04, so that's significant because it's in between that, and then 003, so those are all, and that's significant. Every one of those is significant. These zeros are all significant because they're captured by numbers. There's in between numbers, so they become significant. And then this is significant because it's added after the decimal and after the last number. So because that was put in there for precision, that is a significant digit. So 1, 2, 3, 4, 5, 6, 7 significant digits there. Okay? So when it's a big long string of numbers that just are a placeholder, and then you don't, and then like 1, 2, those aren't significant. But if I added another 0 after that, or another 2 zeros after that, this would now have 4 significant digits instead of just 2. If those are gone, it's just 2 significant digits. Okay? If I threw a 9 here, 9 point, and then made it all that, then all of them would now be significant because they would all be kind of captured. Okay? So 2001, that's 1, 2, 3, 4, because those 2 zeros are captured by 2 numbers kind of, so they're now significant. This one is a little tricky. These are significant. So because those are significant, we use that like captured number rule, just like we did here. So this is a significant digit. So that means that these 2 zeros normally would have been just overlooked. If we didn't have any of that, it would have just been 1 significant digit. But because we have a 0.000, they added, because of the precision, went to tens, hundredths, thousandths place. This is considered significant. So that may as well be a 7 or something, because it's all of them. 1, 2, 3, 4, 5, 6 significant digits there. All right. This one is kind of right, no problem. There's no zeros. So 1, 2, 3, 4. They're just numbers. You count them up, the numbers, whether there's a decimal or not. And then again, this happened again. This is significant. And that was significant anyway because it was between the 2 and a 4. So 1, 2, 3, 4, 5, 6 significant digits again. All right. So that is how we talk about precision and significant digits. And now the bottom half of this, I'm going to do a second video on the most precise to the least precise, and we'll talk about accuracy. on the next video, on the part 2 of the handout. Okay.